Hi everybody and welcome back to our second PowerPoint. This one's entitled, How Does Light Bend? So I'm off to the corner because that's where I belong, and let's get this party going. You see lenses, they are transparent objects. We talked about in our previous PowerPoint how it lets all the light pass straight through it. Well, it not only lets light through, but they bend or distort the light, and they let us see things differently, much like that magnifying glass. With the use of lenses, we are able to manipulate the light, creating images that are exponentially larger or smaller than its true size. With the use of lenses, we are able to bend rays of light, spread them out, or condense them into a fine point. Lenses distort the light, much like these bears in these funhouse mirrors. Some of the lenses make things bigger, others make things smaller. So you look at this little guy here and he's looking at himself going, wow, my face is huge, but he's really got a tiny little head. And this big mirror here, well, it's curved in such a way that it bends the light, making him look much thinner than he really is. To give you an example, I'm going to make myself a little larger, and I'm going to show you a lens. True story. Now I know what you're thinking. Come on, Mr. Eichler, that's a glass of water. It is, but it's also a lens. You see, this water will change the speed of light, and in so doing, will make it appear that this straw is broken. Observe. Isn't that incredible? I know what you're thinking. Wait, what? But watch. When I turn this just right, you can see now that the light makes it look like the straw has been cut and is really sitting down here. You can also note that my finger is really wonky behind it. This is light bending. And what's happening is the light, when it passes from air into water, is actually slowing down. And because it slows down, it makes it distorted. It changes its appearance. Don't move on me, straw. Where I had the magic spot and then I lost it. Pretty exciting stuff, right? Now you can try this at home. Just get a clear glass of water and a straw or a long spoon, fork, knife, whatever. I'm going to save this for later for shooting spitballs when you're not looking. Back to the corner. When light traveling through the air passes through the magnifying glass, it bends it so that it appears to be bigger. This lens is called a convex lens. Oh, look! Bold-faced words and stuff. It's thin at the edges and it's fat in the middle. And this is what makes it appear to change size. The focal point is the point where the light is focused and we can see the image clearly. Now, this is in many ways what our glasses do. Our glasses change the focal point from here to the back of our eyes, and it helps to clear everything up for us so that we can see. Neat trick, right? In other words, the point where the light converges or comes together is known as the focal point. And you can see here that this side of the light crosses this side of the light right here at this point, and this is where it will be clearest and it can be seen best. Now, if you might also be noticing is that, let me get to that in a second. A convex lens is used in telescopes and in cameras and in magnifying glasses. But you kids probably already know about the focal point on a magnifying glass because cool things can happen. This is an example of focusing the sun's light into one tiny spot, thus focusing the light into one intensely hot and bright point. Uh-oh. Sorry, Hal. My fault. Hal's a computer virus. He stops by on occasion. Go away, Hal. When we take a picture with the camera, the convex lens actually flips the image upside down on the film. As I was about to show you before, you can see that when the light crosses each other, it actually flips it upside down. And believe it or not, this is happening right now on the back of your eyeball. True story. The light shines through your iris, through the lens in your eyeball, and it actually gets flipped upside down on the back of your eye. Your optic nerve and your brain flip it right side up again, and we perceive everything as being normal. The focal point on the light actually crosses and the image is flipped upside down, like I just said. Now, this is a convex lens, and you'll note that it is thin in the middle and thicker on the edges. Notice that this is the opposite of a convex lens. Now, an easy way to remember the difference, concave, well, it goes in, like a cave. Aren't you glad I'm here to teach you these things? A convex lens spreads the light out and makes images larger. The interesting thing to note is that the focal point is located behind the convex lens, not in front of it like the concave lens. So you actually see better in front of the lens. Yeah, no, I'll let you figure that one out later. When a film projector projects an image on the big screen, it uses a concave lens to make the image bigger on the screen than the 1-inch film strip that it is showing. As the light shines through the concave lens, it spreads out the light from only a few inches to hundreds of feet wide and long. It's the same thing for our TV projectors as well. Hey, look, that's the end of our show. Thank you all for tuning in and for learning these basic principles of light. We'll see you soon.